how much do we all like symmetry? Usually it's one of the least favorite things that people learn in Algebra 2 Pre-Cal and have to review the calculus. Go figure. I don't know why. It's not really all that hard, but it is a lot to keep straight. Is it finally finished? Okay. I know. Pre-Cal figured out they were leftovers. I didn't tell them, just for the record, but they figured it out. So I had to answer truthfully when they asked, are there leftovers? And I was like, yes, there are. So, if you want to try and sneak leftover donut holes, my advice would be come at 7:55. Okay, 4, 8, 54. Okay. All right, cool kids. My guess, if you're trying to skip lines to set up, that's always a good idea, especially since I go fast. Why? Because college professors will go fast. Why? Because we have a lot to cover. Why? Because we're honest. Why? There's a lot of this. So if you're trying to ever set up notes, just kind of think about if it looks like something where I'm just doing space for aesthetic appeal, just to make things look nice, or whether there's probably something to fill in. What would you guys say on this page? Probably something to fill in. Yeah, it's symmetry and it's a hard concept. If you look at this, there's probably at least one line, maybe two. Probably one will suffice though, because I do have a little bit of space for aesthetic appeal as well. Anyway, just in case you're ever trying to get ahead. You're not quite sure what to do. Sorry, student council emails. Okay. We are finishing section 1.1. Yesterday we talked about different things like what it means to be a solution, the idea that you should never be ashamed if you don't know how to graph a function to just go to a table. You are never without options as far as graphing. If worst comes to worst, you can always go to a table. Doesn't mean the table will be easy, but you can always go to a table. So never tell me, I have no idea what it looks like. I will say, well, did you make a table? Okay? Some of you are like, I might ask, well, did you look at your graphing calculator? That's not really what I'm going to ask. But it is there. It is a resource. It is a tool, but it is also a crutch. And once something heals, or once we're supposed to be getting stronger, we want to go off the crutches to add another. We talked about intercepts, we talked about symmetry. Nope, we're going to symmetry next. Really quickly, in your homework from last night, as you guys were starting, did you guys have any questions on solutions or on graphing with tables or on intercepts? Should have been pretty easy. Sweet, here we go. Symmetry. Thanks for the feedback. It made me feel like you guys started it last night, which is good. I'm happy with them. Those of you that didn't. Okay, x-axis. If you are thinking about a sketch, I'm going to go ahead and show a quick sketch of what x-axis symmetry looks like, what y-axis symmetry looks like, what origin symmetry looks like. A function that has x-axis symmetry, think of the type of symmetry as the fold line. What I mean by that is, why does a butterfly have symmetry? Basically, yeah. Basically with a butterfly, if you fold both the wings, then there is that symmetry, and that one side, in a sense, copies the other side. True? Now, I'm not saying that every butterfly is exactly the same on one side or the other, but what I am saying is there tends to be a type of symmetry. True? So, that line that you're folding it across where you will be able to see the one side copy the other, that's like the type of symmetry that's shown in the name. So x-axis symmetry, you would fold it on the x-axis, and what is above would seem to copy what is below. Let's pretend that was actually somewhat even. Nope, now there's another marker. Pretend that's symmetric. Take two. Too used to it not being oriented. Hold it back. Okay? X-axis symmetry, if you were to fold a graph or a function graph over the axis, it's like, oh yeah, the one side copies the other. I see it. True? So that'd be a sideways parabola. Someone give me an example of something that would then have y-axis symmetry. Yeah, you could do like an upwards facing parabola, right? A concave up. But not just any parabola. It has to be a parabola that is centered on, whose vertex is on the y-axis. As soon as you translate that parabola, it has symmetry. But you cannot fold the y-axis and have it appear. You have to fold the axis of symmetry. Vocab from a while ago. How about origin symmetry? Now this one's tricky. Origin symmetry. It's symmetry about a point, which is a little different than an axis. So if you guys want to think the folding thing, you would have to fold across the y and fold across the x. And then what was in the first quadrant would copy in the third quadrant. What was in the second quadrant would copy in the fourth quadrant. So origin symmetry, one of the most basic ones, is a cubic function. If you guys can visualize, if this was drawn on a piece of paper and if you folded it across the y and folded it across the x, like those old school elementary greeting cards, you like fold it in fours and be like, yay, card. He would copy down there. And then they would have that symmetry. There are snazzy names that technically that will come up. I won't write it yet because, well, you can write it in parentheses if you want to see it early. It'll come up as we review more. These functions, if there is x-axis symmetry, they are called even. That's going to come back. Did I say x? I'm sorry. If there is y-axis symmetry, the function is called even. And it does not necessarily have to do with the degree of the polynomial. You can have a squared function that is not even because it's been shifted off the y-axis. And an origin symmetry is called odd. You guys kind of recognize some of those terms from last year?
Even not.
Never mind. We'll see them. The clues for right now. The clues for right now. Just to keep it basic. When we get into function notation and those sorts of things, there'll be another clue that's kind of more like the definition of what it means to be even or odd, which correlates or corresponds to what it means to have y-axis symmetry or origin symmetry. But for right now, we'll just say that a point xy and a point negative xy for this middle one, they're both going to be solutions. So in each of these descriptions, what I'm saying is that if you were to plug in each of these points, they would both work. It would result in a true statement. So each of these, for each of these symmetries, what xy results in when you plug in should be the exact same thing as x negative y. So for the x-axis, the x remains the same in the sense that it's still in the same right-left placement, but the y's, there's one up and there's one down. You have a point with a positive y and you have a point with a negative y. For the y-axis symmetry, the height remains the same, but there's going to be a point for a positive x on the right and a negative x on the left. Or similarly, I guess you could say if x is negative for an x on the left or an x on the opposite right. And then last but not least, for origin symmetry, if you have a point that's a solution, an xy, then the opposite of x and the opposite of y has to be a solution as well. Now, you can technically test these by keeping them general, meaning keeping them with the notation of x's and y's and negative x's, negative y's. So I'll show you how to do that in examples. But you could also find a point to use as a representative. And if you could find, you could pretend like, hey, I know the graph is over here somewhere, so x is 4, you could find the y if they don't give it to you. You could try, okay, well, if 4, 5 is on this graph, then for negative 5, you could try plugging that in. So you could make it more or less abstract by picking a point. Or you could try to just keep the variables in there as you test it. You guys have this all down, okay? 5, 4, 3, 2. Okay, so without thinking about the graph, because the graph is definitely validated thinking about it, but try to detach from the graph for just a second and focus on the equation alone. I'm going to show two different ways of thinking about it. This is the way where we keep it general, aka keep it with variables. And this will be the way where we get specific. We use a test case, basically. Ideally, it's going to be more helpful in the long run if you can figure out how to do it in general. If the specific point gives you a way of visualizing it, that's not bad either. In general, let me give you a second, go and get the example now. Don't stress about the stuff at the bottom. It's technically just a chart from the book, but it does kind of summarize the procedure, so I'm going to show that to you in just a second. But for right now, let's just focus on the example. Sorry, it's so pixelated, that's rough. Okay, in general, we can think. If you plug in normal x and normal y, well, you're going to get what the equation is that's up above. Okay. If you plug in normal x, normal y, okay, you start with the equation that you're given. In general, you start with that. That's like your xy. But then we have to go through and say, okay, what else works, aka what else comes back to look exactly like this one? We're trying to say, or ask ourselves the question, which is the same? And by which I mean, well, hold on, x-axis symmetry, that's when x stays the same and y flips. Y-axis symmetry is when x flips and y stays the same. And origin symmetry is when both of them flip. So we're going to plug this in one at a time. Instead of y, we're going to plug in negative y. So here's if I plug in a negative y. Here's my main one that I'm trying to match it to. Is that the same? No, because there's a negative next to the y, right? It's not the same. I could move the negative to the other side, but then I have negative x squared and positive 4. Well, that's still not the same. In fact, does not stay the same? Nope. These two don't work at the same time because they do not show equivalent forms of the function. What happens if I plug in the next point? Why?
Because that's something that is square.
Yeah. Where the negative gets plugged into, it's being squared, the argument's being squared, so therefore it's just going to be x squared minus 4, which is the exact same. It means the same thing as the original. Then we would test the last one. The last one says flip the y and flip the x. Is that going to work though? No. Because this part will stay the same, but this part flips. No. It's not equivalent at the same time. So therefore, from that, we could go ahead and say, okay, if for a certain xy, keeping it basic right now, I could make it specific and put little x1, y1. For a certain x1, y1, I'm also going to have a negative x1 with the same y1. Okay, where is it folding to get that? So it's going to have y-axis symmetry. Or you could memorize. Both ways work. Just trying to show you there is a way of visualizing. But at the end of the day, I can go ahead and say, yes, because that is the only point that works, and we can look down here. We tried plugging in a negative x to the equation. And when you replaced x with negative x, there's an equivalent equation. Yes, we can say there's y-axis symmetry. Symmetrical perspective. When replacing x with negative x yields an equivalent equation. If you plug in a negative x, and if it simplifies to be the exact same expression, there's going to be y-axis. Now, I don't know if you need to write this, because technically in my mind, that's what this is for. Plug in a negative x, both of them work at the same time. Y-axis symmetry. So it's up to you. You can go into the book and you can actually write down the procedure as to what we're doing. But in my mind, that's kind of what the page before was for. If you want to see how to do this with a specific point, the problem is you have to find a point that's actually on the curve first. Can you guys figure out a point that's on that curve? 0, -4. Oh, dilemma. Why don't I like 0, -4 for this illustration? It's on an axis. It's not in one of the sides that's going to be folded. Does that make sense? So if you fold on the y-axis, 0, -4 stays the exact same place. It doesn't help. If you were to fold the x, long story short, try not to use a 0. 2, 0? It's also a 0. But a 0 of the y. Try no zeros. 1, -3. That's what I was thinking too. Okay. If I use the point 1, -3, that is on the curve, true? This could be like my x and y. Okay. So I could test, I could ask myself, okay, so for x-axis symmetry, the x would stay the same, the y would flip. And I'm asking myself, does this work or does this not? Is this a solution or is this not? For the y-axis symmetry, I flip the x and I keep the y the same. And for the origin symmetry, I flip both. I'm asking myself, which of these work? How would I see whether or not a solution or a possible solution works or not? Plug it in, plug it in. So does 3 equal 1 minus 4? No. That's -3. Does -3 equal -1 squared minus 4? Yes, positive 1 minus 4 is a -3. So that one's good. And does 3 equal -1 squared minus 4? It's going to be a -3 again, right? Did we come up with the exact same conclusion as the other? Yes. So it's up to you. Some of you get a little confused when we start plugging in variables. Ultimately, that's where we all need to be. But if you do want to think about the specific, it's the long story short of I figure out one point, I'm going to say, hey, which way does it copy? Does it copy across the x, does it copy across the y, or does it copy across the origin, which would be x and y? Is it possible to have more than one type of symmetry? Yes. Can anyone give me an example of a graph that would have all the symmetries? Has something to do with the very next slide and the last topic of this section. I think it's the next slide. Circles, yeah. That has to do circle. Now, specifically, it would have to be a circle centered at 0, 0. If it was shifted, well, it's not going to be able to fold across the y or the x. But if it was a circle, okay. Question, does it have x-axis symmetry? You can fold it, it copies. Does it have y-axis symmetry?
Yes.
Because it copies. Would it have symmetry if I folded and folded? Yep, that's going to be there and that's going to be there. It has all three. However, what does his equation look like? Do you guys remember? What's the equation of the circle? Good thing we have the next slide. Some of you might remember it. You're just being shy. Standard form of the circle. X squared plus y squared is r squared. That's if you have a center at 0, 0. Pause from taking notes for just 1 second. I'll encode it to you right after this statement. Why does it make sense from this equation, not the graph, from the equation that it would have all three types of symmetry? Yeah, right.
They're all the same.
What do you mean?
They're all squared.
Right. And so since everything is squared, well, we're not really plugging in the r. Since the x and y are both squared, Thomas, what does he mean by x? Since they're squared, they're the same.
You change them to negatives like it says, it just makes it back to positive, so it's the same answer.
Exactly. Nothing is going to become opposite. If you plug in a negative x, like Ryan said, it stays the same. It's just going to be x squared. If you plug in a negative y, it's going to stay the same. Y squared. If you plug in a negative x and a negative y, it's going to stay the same. Does that make sense? Who's HK? I shouldn't say who. Sorry, I personified it. What's HK? The center. Sean tried to get me to start calling everything she. I haven't gotten that bad. But you say who instead of calling her. You can say he more often than she. Where's he going to talk about a graph? Center, HK. So can a center, yes. Can a center be shifted? True. Can a circle be shifted? Yes. And how will we see that? How will we be able to recognize that with the H and K? And then what is the other part of the equation besides the independent X and the dependent Y? We're used to those. Who else is there? And what does R stand for? You all just said it. 3. Okay. And then keep it parallel. Why do I write in cursive? Because I should have never taken it out of elementary schools. Alright, cool kids. So with that, ooh, remember our book digs deeper? I want you guys in your group to collaborate and try to get me the answer to that example. Ready, set, go. Not an option.
Wait, are you saying 4 minus 2? Wait, no. So you have the center negative. So the radius is 7, right?
Functions, y is always by itself. But if you have something that
You actually gotta stay focused,
y is not focused. So it's going to be a weird one. It's not going to be a normal function that we're used to. It's going to be one of those like basically y squared.
minus h 3.
And in things like trig, sometimes trig.
Because if I saw it, I still think we would
So K is 4.
solve for it.
Oh, that's the center point.
It only gravity.
Yeah, you're right. 4 minus the squared, 4 plus 16 equals 7 squared. R squared equals 12.
H and K, H and K.
Groups that have it, give me a thumbs up. How can you check whether or not you're right, besides asking me or another group? How? How? How do you get in your calculator? For the y squared. Oh, come on. What's the only way that we can graph in our calculator? We have to get both by itself. So, if you think you have an answer, check it by graphing it. And I want to see if you can get the entire circle on your graphing calculator, not just half. And see if your equation puts it in the right spot. Of course, I did it mental math. That's always dangerous. Hopefully, you guys, when you were filling in, you got x plus 1. Y minus 2. Who is R? How'd you find it? Did anybody do the Pythagorean theorem? Anyway, you could have done Pythagorean theorem, so you would have had, there's 1 and there's 3, so that would have been a length of 4, and that could be the length of 2. 16 plus 4 is 20, the square root of 20 is the radius. Is that right with that square root squared?
Yep.
So what your final equation should have been, double check me. To be honest. Does that look right? You guys don't like that way of doing it? You have d equals, should have had x2 minus x1, y2 minus y1, right? Right? But then you plug in r squared. So square root squared, you just get 20. Does that make sense? Okay, so what do I need to change in my calculator? Subtract x plus 1 quantity squared, square root both sides. Oh, this is wrong. Lo siento. I tried to make it all nifty and short, but that doesn't work. I need 2 minus. I was being lazy. Oh, brother. Forget it. 2 minus. Is that right? Because to get y by itself, you would subtract the whole x plus 1 squared expression, right? Then you would square root, so 20 minus x plus 1 quantity squared, then square rooted. Then you would have to add the 2. And adding the 2 is on the outside, and hence why I put that at the very beginning, because I don't want to do a square root plus 2. That's awkward. Is that better? It doesn't look like a circle. How come? First of all, my window's a little bit short. I think you need to go up to like 8 or something like that. I was trying to make my window look like their window. Still doesn't look like a circle. Is it in the right place though, kind of? Why does it look all squished? Oh, come on. Remember the shape of our graphing window is what? It's a rectangle. So how do I make it look all nice and pretty? Do you remember? Zoom square. My smartboard freaks out every now and then. Like right then. So you could try zoom and then zoom square. There he is. All nice and pretty. But it's not a circle. My calculator fails. Can anyone tell me why it's not connected? Especially anyone interested in photos. No? You guys see pixels? Come on, you know what a pixelated picture looks like, right? Okay. Do you see pixels on the screen? Yeah. Because this is not a perfect smooth curve unless you have one of those nice ones with a light up screen. I think those ones are smoother, but do you guys still have pixels on those two? Okay. So it's pixelated, meaning it's like, oh, I have to go a little bit over. Okay. I have to go a little bit over. Okay. I have to go a little bit over. Okay. It's not graphing infinitely many points. It's graphing a few points here and here and here. Now they're really close together, but they're graphing different points. What's happening between here and here? It needs to go over such a small amount, it cannot make a pixel for it. Does that make sense? So it's like, I need to go over, and it's like, oh, stink, there is no over. There's no pixel, because if it does another pixel, it's going to go beyond. The decimal is so small. So where we know to connect, the calculator cannot because of its programming. Now, the new light-up screens, does it actually connect? Does it have like a built-in? No. So, do our graphing calculators have limitations? Yes. If you were using a nice app like Desmos, it would probably be connected. But ours, no, it's not. All right. Any questions on how to get the equation of the circle or how to graph a circle? Yeah.
But how come, like, if you were to fold it over, it's still not totally even?
Ah, because we didn't actually ask the question on this one. I didn't ask you for this example if it had any symmetry. So let's pause and think about it. Does this equation have any symmetry? Now you were just looking at it, it has none, right? You can't fold the y and have it copy, it can't fold the x because it's been shifted. How would we see that when we go to plug in a negative x? If you plug in a negative x, can I say that negative x squared is a positive? Oh, there's a plus 1. So since there's a plus 1, in order to square, what do I have to do with that negative x plus 1? To square it. you'd have to FOIL it. And when you FOIL it, you would have negative x times negative x is positive x squared. But you would also have a negative x plus a negative x, a negative 2x, that is different than the positive 2x that's here when I FOIL it. So long story short, if you put in a negative and it's a little binomial, when you FOIL it, it has to stay the same, and that negative x would not, part of that FOILing, part of that expression would be different. Does that make sense?
Yeah.
And same thing with the y when I went to go FOIL it. Kiddos, speaking of which, bad math kills. What do you see up there? Which of the poor little animals is going to die every time you FOIL wrong?
Oh.
How easy is it for, if you were tutoring little Algebra 1 kids, just learning how to deal with binomial expressions? What are they going to do with that every time? X squared plus 9, I got it, I'm done, I know how to square things, but what's wrong? The mistake is x squared plus 9. What kills is every time, kills your points anyway. What kills is when you make that jump. How do you properly do this every time? Binomial multiplication, you have to FOIL. True? And the only time the outer and the inner are going to cancel, so you only have a squared term and another squared term with one sign in between, and it's always going to be a minus. The only time the outer and the inner disappear and there is no middle term is when? When there's a difference of squares, there's a positive and a negative. X plus 3 times x minus 3. If they're the same, there is always a middle term. Okay. Off my soapbox. Section 1.2 done. Dun 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 dun. Homework due tomorrow. Sweet. Section 1.3. Here we go. Oh, I did give you one more. Okay, after this point, I'm never going to tell you how to do your table of contents again. Section, oh, keep going. You guys see why I'm jumping into 1.3? Lines. I can do lines. We'll try not to finish this today, so we still have something to do tomorrow. But don't worry, you can finish 1.3. We'll just go on to 5. Oh, that's right, because we're supposed to split it in half. But so far, does this really seem like, oh, this is going to be a crazy hard test? Oh. Never mind. Maybe we'll just have a quiz. But section 1.4, 1.5 is a little harder. So. Alright, you wanted to hear that, but. Oh, he's still gone. Maybe I know what's going on.
Probably.
Oh, it's 6 o'clock. Oh, you said probably 6. He's been gone. Joseph, did you send me an email last night about book cover?
Yeah.
Cool. Caroline, did you send me an email about book cover? Perfect. Just double checking. The rest of you guys were all good? Ooh, except Colby's haven't checked it yet. Kiddos, I want you to fill in underneath equations of lines as many ways as you know of writing an equation of a line. There should be at least 3 different ways. Ready, set, go. See if you can figure out all 3. Equations of lines. There are at least 3 different ways of expressing an equation of a line. Can you think of all 3 of them? Those should have been the first two you thought of. What's the third one? The awkward one that we don't really like to look at. Actually, you probably don't like the second one. Slope intercept. Slope intercept. How's that go?
Y equals supposed to
And by the name, you know what two parts do you need to fill into that equation? The slope and a y-intercept. Good. D is the y-intercept, quick reminder, M is the slope. 0, Point slope, how's that one go? Nice, equals. As the name denotes, what do you need? Any point and the slope. So now's a good time to talk about slope. How do we find slope? Oh, I have a place for it. We'll wait. But yes, it is rise over run. What's another way of writing rise over run? What's another way of symbolizing, symbolizing rise over run? What's a good way of symbolizing changing? Got it. And this only works, this equation only works for lines, for linear functions. That begs the question, can there be slopes to curves? Can curved objects have slopes? What do you guys think? No? I'm just being facetious, but if it's a no, then we better stop skiing. No curves have slopes, we'll forget that. Do curves have slopes? Yeah, they do. But how do we denote them? Man, second semester already. Tangent lines. But how many slopes does a curve have? All kinds. You guys know that because if you've ever gone downhill on something, especially something where you could get hurt if you fell off of it, you know that at different points of that hill you are going different speeds, right? And if you remember from earlier math, slope and rate of change has something to do with it or with each other. Okay, sorry, that's calculus. Let's come back. Special slopes. Oh, standard form. We forgot one. He's the awkward one where you have the x and the y on the same side of the equation. Like 3x plus 2y is 1. It's gross because you can't see a slope, you can't see a point without getting y by itself. But it does show up from time to time, and it is what it is. Special slopes. What do you guys think? What are special slopes? Nothing? Special slopes. What are some special lines that would have special slopes? How about that? Ah, there we go. Horizontal and vertical. These are the ones that we tend to mess up and get all confused-ated. Yes, that's a great word. Not sure exactly how legal it is. But horizontal, vertical. Horizontal, remember, it's the same direction as a tick mark on the y-axis, right? Which is y, it's a y equals number. Y equals 2, y equals -1, y equals 4, etc., etc., etc. Y equals makes a horizontal line, but even beyond that, let's go back to skiing. If you were skiing on this, what's your slope? 0! Are you being helped at all? Nope, so it's not a downhill slope. Are you having to go against a hill? Nope, so it's not an uphill slope. It's a no slope. You're just going, right? Cross-country skiing, well, I don't know. Very flat cross-country skiing. Vertical, though. If you have a vertical line, first of all, that's just like a tick mark on the x-axis, which is why vertical lines are x equals a number, x equals 2, x equals 0, x equals, etc., etc. But what if you went to go ski that guy? Get a parachute. So, what kind of slope is that one? Undefined, because that's what you're about to be if you don't have a parachute. But if you want to be super snazzy, it's not actually undefined as in there is no way of expressing it. It's undefined as in it's an infinite slope. If you want to think, why would it be an infinite slope? Well, you had a slope of 1. How steep is that? Up 1 over 1. Slope of 5. Slope of 100, 1,000, 1,000,000, 1,000,000,000,000, 1,000,000,000,000. It's going to keep on getting and inching closer and closer and closer and closer and closer to what? Infinite slope. All right, cool kids. That's section 1.3. We have what? 45 seconds? Let's see what we're going to do tomorrow. Ah, you guys know this. I can even write it down fast. What's parallel? If two lines are parallel, then their slopes are the same. We know nothing necessarily about their points. But if two lines are perpendicular, then their slopes are related how?
Inverse.
I don't like the word inverse. Opposite, aka opposite signs. Reciprocal, as in, if one is 2, the other is 1/2. Alright, cool kids, your homework tonight is finish 1.2 and hey, alright, cool kids, see you later. Happy nutrition. I will see you when I see you. I'll be here. Do you guys have any questions? Yeah.
When should I come for the quiz? Should I take it after school or 7th period?
Either one would be just fine with me, because I'll be in there. Thanks. Yes, I'll have it ready for you. Make sure to bring calculator. Yeah.
Can we go back to the last slide?
Should we start 3rd quarter?